Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 4, Section 1, titled Absolute Value Equations and Inequalities. By the end of this video, you will have reviewed ratios and rates and end up with solving proportions. You will work to understand the concept of a unit rate, and then you'll be converting these rates from one type to another using dimensional analysis. When it comes to proportions, you will be solving them using the multiplication property of equality, cross product multiplication, and solving multi-step proportions. Finally, you will review skills for solving real-world rate conversion problems. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find this video to be helpful. Thank you. Okay, so before we get started, let's look at a few definitions. A ratio. So what is a ratio? A ratio is a comparison of two numbers by division. It's all it is. You're comparing two different numbers by division. Okay? The ratio of 4 to 6, right? That's 4 divided by 6. A rate. If A and B represent quantities measured in different units, okay, like feet and seconds, two different quantities, then the ratio of A to B is a rate. A unit rate. A unit rate is a rate with a denominator of 1. That'd be like miles per second, miles per 1 second, feet per hour, okay? Miles per gallon, per single gallon, per 1 gallon, divided by 1. Unit analysis or dimensional analysis is what it's called quite often. When converting from one unit to another, as in hours to minutes or minutes to hours or whatever you want to convert, miles to feet, feet to kilometers, whatever you want to convert, okay? You must decide which conversion factor will produce the appropriate units, the units you want to end up with. This process is called unit analysis or dimensional analysis. We say that quite often, dimensional analysis. This is heavily used in chemistry, by the way. So if you're going to move into chemistry, this would be very important to understand this. A proportion. A proportion is an equation that states two ratios are equal. Like A over B is equal to C over D. Two ratios are equal to each other. And what are extremes of a proportion and the means of a proportion? In the expression, A divided by B is equal to C divided by D. A and D, the peach-colored or salmon-colored letters here, A and D are the extremes. So that's the extremes of the proportion. The means of the proportion are the B and the C. So it's the outer, like A and D are outer and B and C are inner. Kind of look at that relationship and get the outer, the numerator of the first and the denominator of the second are the outer, and the denominator of the first and the numerator of the second are the inner. Okay? Okay, objective 1. The slide is 1A because there's going to be another slide that kind of fills in the rest of this objective, but I'm not going to be presenting it at this moment. Ratios and rates. A ratio is a comparison of two numbers by division. We talked about this in the definitions above. The ratio of A to B is perhaps A colon B, okay, or A divided by B, where B is not equal to 0. If A and B represent quantities measured in different units, like A is in feet and B is in seconds, okay, different units, then the ratio of A to B is a rate, like feet per second. Okay, a unit rate is a rate with a denominator of 1. So that's what, when it gets to the per second, would be per 1 second, per mile, per gallon. That's a unit rate, they call that. And you can write this rate, let's say if the rate was 40 miles per 1 hour, you can write it as 40 miles per hour. You don't have to say the 1, because it implies, when you say per hour, it implies 1 hour, per 1 foot, per 1 second, per 1 year, per whatever you say there is always implied to be 1. Okay, example 1, using unit rates. So comparison shopping, they say here. So the table at the right gives prices for different sizes of the same brand of apple juice. Find the unit rate or the cost per single ounce for the 16-ounce size. So what do they want us to do? They say, well, take the 72 cents, the $0.72, and divide it by 16 ounces. That'll give you the dollar cost per ounce. Okay, that's going to tell us what the cost per ounce is. It says divide the numerator and the denominator by 16. So we did it here. We said 72 cents right here divided by 16 and 16 ounces divided by 16. Well, what does that give you? That gives you, if you take a look at it, it's going to be 0.0045 dollars or 4.5 cents per ounce. And the 16 over 16 is 1. So there's the 1 for the 16 divided by 16 is right here. Okay, there's the 1 right in there. But we don't use that 1, right? Because it's per ounce. It's per single ounce. So you don't need to add a 1. So the 16s disappear. And this divides out. So it's 0.0045 dollars or 4.5 cents per single ounce. So that's how you can kind of do this. So the unit rate here is 4.5 cents per ounce or dollars, 0.45 or $0.045. Okay? Okay, example 1, check your understanding. Solve. Find the unit rates of the other two sizes. Well, the other two sizes are based on the previous slide where we had down here in the corner, we used the 72 cents per 16-ounce bottle. Now they want us to use the $1.20 and the $1.60. $1.20 for the 32-ounce and $1.60 for the 64-ounce. So why don't you go, this is a check your understanding, so why don't you go ahead and give these two a try. And then when you come back, we'll work them together. And what it's asking here in problem B, it says, which of the three sizes has the lowest cost per ounce? So you'll be able to tell that when you do the problem. So go ahead and work these out, and when you pause the video. When you come back, we'll do them together. Okay, I'm assuming you've taken the time and you've done this on your own, so let's look at it. So for the 120 ounce, 120, excuse me, the $1.20 bottle of the 32-ounce bottle of apple juice, what did we do? We said we have $1.20 per 32 ounces, $1.20 over 32 ounces, $1.20 per 32 ounces, and that equals, we want to convert that into a unit rate or a unit size, whatever, however you want to call this, right? So that would be in something per a single ounce, per 1 ounce. And so in order to do that, we're going, just like we did on the previous slide, we're going to divide the top by 32, and we're going to divide the bottom by 32. And when we do that, this 32 cancels this 32. And what you're left with right here is 1 ounce, right? 1 ounce. So, and now if you take the top, the $1.20, and divide it by 32, if you take your calculator or however you run it, you're going to find out that the price is $0.0375 per ounce or 3.75 cents per ounce, single ounce per ounce. That's one ounce. Okay, and there's your answer for that. The second one is we do the same thing for that $1.60. $1.60, divide the top and the bottom both by 64 because we want to clear this 64 here so that we have just 1 ounce on the bottom, right? So when we do that, we're going to divide the top by 64 and we'll divide the bottom by 64, and you're going to get 20 or 2.5 cents or dollars. You're going to get 0.025 dollars per ounce. And now looking at these two answers, you've got the 3.75 cents per ounce and you've got the 2.5 cents per ounce. Well, the cheapest is going to be the point or the 25 or the 2.5 cents or the 0.025 dollars per ounce, and that happens to be for the 64 ounce size right here, the 64 ounce size. Okay, objective 1b, so this is the second slide from objective 1, ratios and rates. So to change one unit of measure to another, you can use rates that equal 1, given that, for instance, 60 minutes equals 1 hour, both 60 minutes per hour and 1 hour per 60 minutes, they both equal 1, because an hour is 60 minutes and 60 minutes is an hour. So in this case, you can use 60 minutes per hour, 60 minutes per 1 hour as a conversion factor to change hours into minutes. So let's take a look at it. Here's the example. So we start off with, we want to change 7 hours into minutes. So what are we going to do? Well, the first thing we'll do is we'll put a 7 hours over 1. We'll turn it into a fraction, right? With a 1 in the denominator, which you can do that automatically. And then you're going to multiply that by 60 minutes over 1 hour. 60 minutes over 1 hour. And when you do that, you're going to get 7 times 60, okay, which is 420. And you're going to get hours dividing hours out. So this hours will divide this hours out. So the hours will be gone and we're left with minutes. And we're going to end up with 420 minutes because we divided the hours out by multiplying by this unit factor in this particular way. So you divide out the common unit, which in this case is hours, and the result is then in minutes. So when converting from one unit to another, as in hours to minutes or minutes to hour, you must decide which conversion factor will produce the required unit. This is called unit analysis or dimensional analysis. And I prefer dimensional analysis. And it's very big. If you ever get to chemistry in the college level, or even high school level, dimensional analysis goes on all day long. You need to understand this dimensional analysis. Okay, example 2, converting rates. Speed of a cheetah. A cheetah ran 300 feet in 2.29 seconds. What was the cheetah's speed in miles per hour? So now we're going to make two conversions. We're going to convert the speed is in seconds and they want it per hour. And they also said the cheetah was running in feet in 2.92 seconds, and they want the cheetah speed in miles. So we're going to go from feet per second to miles per hour. So there's two conversions. So you need to convert from feet to miles and seconds to hours. So what do we have? We start off with what we're given, the 300 feet in or per, okay, 2.92 seconds. So we're going to write it 300 feet in 2.92 seconds, or per. The division or the fraction bar here could be called per. 300 feet per 2.92 seconds. Okay, that's where we start. Now we want to convert. We can pick either one. Doesn't matter which. We can do them all across the line here. So the first one that's chosen is to convert miles to feet. So we want this in feet per second. We're going to convert it to miles per second right off the bat is what we're going to do, right? So you put what the unit you want on the top. You figure out which unit conversion you're talking about here, which factors. So we're talking about miles and feet. So it can either be 1 mile per 5,280 feet, or it could be 5,280 feet per 1 mile. You can flip them either way. They're equal no matter how you look at it. But we want to get rid of the feet and convert the feet on the top here by the 300 right here. We want to convert that to miles. So we're going to multiply by the factor that has the miles on top and the feet on the bottom. Okay, so there we have it, 300 feet per 2.92 seconds times 1 mile per 5,280 feet. So now we've taken care of the feet. Now let's do the seconds. And then that is times 60 seconds over 1 minute. Okay, because we want to get rid of the seconds. Here we have a seconds on the bottom. We want to get rid of that and convert that to minutes on the bottom. So to get the minutes on the bottom, you're going to multiply by the factor that has the minutes on the bottom. So wherever you're trying to, whatever unit you're trying to replace, if it's on the top or the bottom of the fraction bar, you you replace it with the unit factor that has the dimension you want in the same location. If it's in the denominator, then you have to have the seconds, or it's in the opposite location. If you want the seconds removed, you have from the denominator, you have to have seconds in the numerator to remove it. And that leaves you with what you're looking for in the bottom, in this case, to replace the seconds over here. So the minutes on the bottom will replace the seconds on the over there on the left. So we're going to multiply this now by 60 seconds per 1 minute. 60 seconds per 1 minute is the same as 1 minute per 60 seconds, but we want the seconds on the top because it's going to take care of removing the seconds in the denominator on the other at the beginning of the equation. So now we have all of it. 300 feet per 2.92 seconds times 1 mile per 5,280 feet times 60 seconds per 1 minute. And then we're going to hours times 60 minutes per 1 hour. So we went from seconds to hours, seconds to minutes, and then minutes to hours. And you could have done the whole thing at once. You could have done, um, in terms of seconds, you could have went from seconds to hours right away by saying 3,600 seconds per hour. You could have done that too and gone right straight to the hours, but we stretched it out to have more factors, okay? So we're not going to worry about that. We're going to leave that out of the problem. We're not dealing with that. Okay, so now that you've factored it all, now you're just going to cancel out the units that you're trying to cancel out and leave the ones you want behind and do all the multiplication from on the numerator and the denominator, whichever ones you're doing. So let's look at it. You got 300 feet. The feet are gone because we canceled here. The feet are canceling feet. The seconds over here are gone because we're canceling seconds right here and seconds over here. And the minutes are gone. Minutes here are canceling the minutes here because we want an hours on the denominator. So what do we have now? We have 300 times 1 mile times 60 times 60. There's your 3,600. And then we have divide by 2.92 and divided by 5,280 feet. Okay. And when you do all that multiplication, you're going to end up with approximately 70 miles per hour. Well, that's pretty darn fast. The cheetah's speed was about 70 miles per hour. Okay, example 2a, check your understanding, it says here. So, the directions. A sloth travels at 0.15 miles per hour. Convert this speed to feet per minute. So what we're going to ask you to do is pause the video. It's just like the previous slide, so if you need to slide back and look at it. But pause the video, work this out, and when you come back, we'll work it together. Okay, I'll wait for you. Okay, now that you're back, what was it? A sloth travels at 0.15 miles per hour. Convert this speed to feet per minute. Okay, so we're going to start off by writing what does the sloth do? The sloth travels at 0.15 miles per 1 hour. Okay, 0.15 miles per 1 hour. And we want to convert I'll get rid of the hours. So we have to multiply with a unit converter here, if you will, that has the hours on the top and what we're trying to get to on the bottom in this case, because the hours are on the bottom over here. We got to cancel it with hours in the numerator over here. And we want just minutes left in the denominator. So then we'd have 0.15 miles per 60 minutes, right? That's kind of what we're ending up with. We're going to be dividing 60 into this. Anyway, so then we also want to convert the miles to feet. Convert the speed to feet per minute right there. So how you do that is you put the feet on the top and get rid of the miles by putting the unit miles on the in the denominator. So the hours will cancel out and the miles cancel out. The hours are all gone. And what are you left with? You're left with 0.15 times 5,280 divided by 60. Okay? And when you do that, you'll get 13.2 feet per minute. Okay, objective 2a, solving proportions. A proportion is an equation that states that two ratios are equal. in this case here, A divided by B is a ratio, and that's equal to C divided by D. That's what this equation is. But B has to be not 0, and D cannot be 0. Otherwise, you're dividing by 0, and we know from for a long time now that you cannot divide by B and D. These two terms here cannot be equal to 0. So you read this proportion as A is to B as C is to D. So it's A, the fraction line here is to. A is to B as the equal sign, we're going to say as. A is to B as C is to D. Okay? And for this proportion, A and D are the extremes, and the proportion of the proportion, and B and C are the means of the proportion. Another way to see this proportion written is A colon B, or A is to B, we say is to for the colon, A is to B as, the equal sign is always pretty much an as, A is to B as C is to D. And from here now, we can see these extremes and means that they're talking about. A and D are the extremes. Well, how do I see them as extremes? Well, if you look here, A is on the outside and D is on the outside, on the extreme ends. And B and C are in the middle. They're the means. They're on the inside, okay? The extremes and the means. So you can use the multiplication property of equality to solve a proportion for a variable. Well, I'm going to show you why and how you do that. So A is to B as C, A is to B as C is to D. Well, we can move these and manipulate this, right? Any one of these variables, we can manipulate them. They're all variables right now. So we can, to get rid of the B in the denominator, we can multiply both sides by B. So when we do multiply the left side by B, the numerator by B over the denominator, we get a B on the right-hand side, but the B's on the left-hand side will cancel each other. And when you multiply by D on the numerator on each side, the numerators on the right-hand side is the D's will cancel, but on the left-hand side, you'll be left with the D. Okay, so when you do that and you simplify, these B's cancel and these D's cancel, and you get A times D is equal to B times C. So now you see how you can move these around using standard equations. It is the standard equation. Okay, and as you know, equations are always true. They're always true. So once you have your proportions, which with an equal sign, you can move your proportions any way you need to. Okay, so example 3, using multiplication property of equality, we have solved T is to 9 as B, excuse me, T is to 9 as 5 is to 6. So we want to solve for T. And how do we do that? Well, we could have done what we just said on the previous slide. We could multiply each side by 9 and remove the 9 on the left-hand side and have T equals 5 times 9, 45 over 6. Then we can multiply both sides by 6 and then get 6t and 45 times 6, whatever that is. I don't know offhand here. Or you could do the least common multiple. This is how we chose to do this one because 9 and 6 have a least common multiple of 18. So we can multiply both sides by 18. That way we're not getting huge numbers to deal with. We're going to stay in a nice realm here of small numbers. So when we do that, when we multiply each side by 18, the least common multiple of 9 and 6, we're going to get 18 divided by 9 is 2, so we're going to get 2t, and we're going to get 18 divided by 6 is 3, and 3 times 5 is 15, okay? So we're going to get 2t equals 15 when we simplify. And now we have to get the t by itself, which is remove the 2. And we do that by dividing both sides by 2, and when we do that, these 2's cancel, and this 15 gets divided by 2, and you end up having t being equal to 7.5. Okay, example 3, check your understanding. So here are 3 problems that you can work on yourselves. Stop the video, pause the video, go ahead, try them. When you come back, we'll work on them together, okay? So I'll wait for you. Okay, I'm assuming you stopped the video, you paused it, you worked the problems, and now you're back with me running again. So let's go ahead and look at them. So on the first one, we have x over 8. I'll write here, x over 8 is equal to 5 over 6. So what is that? X is to 8 as 5 is to 6. Well, from the previous slides, we know that we can multiply this just like it's just a standard equation, right? We're going to solve for x. So in order to solve for x, we're going to multiply both sides by 8. So when we do that, we're going to get x is equal to 5 times 8 divided by 6. And that, what does that equal? 5 times, this is 5 times 8 is 40 divided by 6. And 40 divided by 6 is 6 goes into 46 times. And there's 4/6 remaining, or 2/3. So x is equal to 6 and 2/3. Okay, let's look at B. So here we have y is to 12 as 4 is to 7. We're going to multiply both sides by 12 to put the y by itself. So now we're going to have that equals, right? Y is equal to 4 times 12 divided by 7. And y now equals 4 times 48 divided by 7. And 48 divided by 7 is what? 7 goes into 48 6 times. And that's 42. So there's 6 remaining, and 6/7. 6 and 6/7. Okay, let's do this one. C. 18 is to 50 as m is to 15. Okay, so let's look at this one. So we're going to multiply both sides by 15 now to get the m by itself. So now I'm going to say 15 times 18 is over 50 is equal to m. Oops, I just wrote a y, and I don't know why I did that. But let's try and write an m this time, is equal to m. Okay, so I'm just going to put the numbers on the other side. So m is equal to what? 15 times 18 is 270 divided by 50. And that is equal to, m then is equal to 50 into 270 goes 5 times. And there's 270 minus 250, so to speak. We have 20 remaining. So that's 20/50ths, or 5 is equal to, we could say 0.4 if you want to carry it out that way, 5.4. Okay. Okay, you could have wrote this 2/5. Also, it could have been 5 and 2/5 if we wanted to keep it in fractions. Okay, hopefully you did well on that. Okay, objective 2B, solving proportions. So what does this property say here? The property of cross products of a proportion. So I think we just looked at this previously. So it says here that if A is to B as C is to D, then A times D, A times D, that's the cross multiplier, A times D is equal to, and I'm going to change colors to red, is equal to C times B. We did this multiplication earlier. And then to see that in reality here, you get, so what do you get? Here's an example. 2/3 is equal to 8/12, or I can say 2 is to 3 as 8 is to 12. So we're going to multiply both sides by 3. That's going to give us this 3 times 8. The 3's will cancel on this side when you multiply by 3. And you're going to multiply both sides by 12 to cancel this 12 here on the bottom here. So when you do that, you're going to get 2 times 12 is equal to 3 times 8. And is it? 2 times 12 is equal to 24. And that's equal to 3 times 8, which is equal to 24. So that's 24 is equal to 24. And that's true. Okay, example 4, using cross products. So we're just going to now put this to work, this example we just saw. So what are we going to look at? We're going to look at y is to 2.5, right here. Y is to 2.5 as negative 3 as negative 3 is to 4. Okay, so we have a variable in here, the y. We're going to solve this. So here we have it here. Negative y is to 2.5 as negative 3 is to 4. We're going to multiply, in essence, we're multiplying the 4 on this side, y times 4. We'll get rid of the 4 on the bottom, and 2.5 on the other side, right? So you have 4 y times 4 and 3 times 2.5. Okay, so we multiply the 2.5 up here, and we multiply the 4 up here. Okay, so now we have that. So what do we have? You have 4y is equal to negative 7.5. Okay, because 3 times 2.5 is 7.5. So it's negative 7.5. So now we have to cancel the 4's, right? Get the y by itself. And when you do that, you're going to get y is equal to negative 1.875, just by simplifying. Just a little bit of cross multiplying. Okay, now it's your problem. Go ahead, your turn. We got 3 problems for you to try. So why don't you take some time and stop the video, work these out, and when you come back, we'll try and work them together, okay? So let's give it a shot. Okay, now that you've had time to do that, let's go ahead and try to solve each one. So to begin with, we've got x, or let's see where's that, there it is. So we have x as to 4 as 25 is to 12. So we're going to multiply both sides. What they want us to basically do is multiply both sides by 12 and both sides by 4. But if you realize you're going to end up with a 12 over here, you're going to end up with 12x, okay, is equal to something. Well, the 12, and when I go to clear it, I'm going to divide both sides by 12 again, and I'm going to get right back to where I was when I started, dividing by 12. So all you really need to do is clear the x. Undo the division involved with the x. So x is equal to 25 times 4 divided by 12. No more to be done. You just have to multiply this out. 25 times 4 is 100 divided by 12, and x will be 100 divided by 12 will be what? It's going to be 8, because that's 12 going to go into 100 8 times, because that's 96. So it's going to be 8, and then there's 4 twelfths left. 4 twelfths, or 1/3. Okay, so let's do it here. So we're going to do the same thing. There's no reason to move the 5 or multiply the 5. It's going to stay right where we want it. We're just going to multiply the 7 times both sides. So we're going to get 7 times 24 divided by 5, and that's going to be equal to y. And so now you're going to carry this out a little further. We're going to say 24 times 7 is what? So that's 7. If it was 7 24s is 175, right? Minus 7. So 175 minus 7 is 168. So it's 168 divided by 5. And when you do that math, you're going to get 33.6. Okay, last one. 54D, 54, this is a little different now. You will do 2 multiplications because we have to get the D on top, is equal to 72 divided by 64. Well, in order to do this, we're going to put the D on top, which means we're going to multiply both sides by D. And in doing so, the D's on the left will clear. So you're going to get 54 is equal to 72 times D over 64. 54. Now you're going to multiply both sides by 54, 64 rather, because you got to get this, and you got to get the 72 on the bottom. So what we're going to do is we're going to multiply both sides by 72 divided by 64, the inverse, right? We know about the multiplicative inverse. So we're going to multiply the left Well, let me carry it over. So we're going to multiply 64 over 72 times 54 is equal to 72 64ths times 64ths over 72 times d. These are going to cancel. These are going to cancel right now. And we're going to multiply this out. So we're going to get, well, let's go ahead and move this over so we can see it a little better. We're going to get d, and I'm going to flip it around, equals, I'm just putting the d on the left and the numbers on the right. I'm going to write it again, 64 times 54 over 72. And that equals 64 times 54 is 4160 divided by 72. And now when we simplify this, we're going to get 4160 divided by 72, and that equals 48. Okay? So D is equal to 48. Good job. Okay, example 5. It's a real world problem we're going to solve here. In 2001, Lance Armstrong won the Tour de France, completing the 3,454-kilometer course in about 86.3 hours. A lot of bike riding there. Traveling at his average speed, how long would it take him to ride 185 kilometers on a different venue, so to speak? Be using his average speed. And what is his average speed? His average speed we're going to pick up from the speed he was riding in the Tour de France. So we're going to so round your answer to the nearest tenth, it says here. So we're going to let t be the time that it needed to ride the 185-mile-an-hour trip. And if you had not miles, kilometers per time, now you got speed, right? Kilometers per minute, kilometers per hour, or whatever. So we got time. And in our case, it was hours. So that's the average speed is going to be in hours now, or in kilometers per hour. So what are we going to write? We're going to write what we started with from the Tour de France, which is 3454 is to 86.3 hours. 3454 kilometers is to 86.3 hours, as 185 kilometers is to some t. We want to know how long it's going to take to ride the 185 using his average speed from the Tour de France. Okay, we wrote the equation. Okay, so now we're going to cross multiply here. We're going to, since the t is on the bottom, we're going to multiply t to both sides and 86.3 on both sides. And in doing that, we're going to get 3454 kilometers times t, because we multiplied the t here up here on the top. And then we're going to multiply the right-hand side, the 185, by the 86.3. That'll be over here on this side, okay? And when we do that, here it is. 3454t is equal to 86.3 times 185. So now we've cleared the denominator on both sides, but we have t that has a coefficient. We need to get rid of that. So what are we going to do? We're going to divide both sides now by that coefficient. And in doing so, we're going to have t is equal to 86.3 times 185 divided by 3454. And when we simplify this, we're going to end up with t being equal to 44.6 hours. That's rounded to the nearest tenth. Okay, so traveling at his average speed, it would take Lance Armstrong about approximately 4.6 hours to cycle 185 kilometers. Okay, example 5, check your understanding. Suppose you walk 2 miles in 35 minutes. A, write a proportion to find how far you would walk in an hour if you were to continue at the same rate. Solve it for x. You can use an x for your, okay? So write a proportion to find how far you would walk in an hour if you were to continue at the same rate. And then once you do that, then solve the proportion for x. So you're going to get proportion with an x variable, and then you're going to solve for that x variable. So the first one, A, is just write the probability or the equation here, the proportion that we're going to deal with, okay? So I'll give you some time and then we'll move on. Okay, example 5, check your understanding, right? So now that you've had the time to work on this problem, let's go ahead and solve it. It says write a proportion to find how far you would walk in an hour. So they want you to limit it to 1 hour. If you were to continue at the same rate as the rate that they listed at the top, okay, and then solve for x. So what is that rate? The rate that you were walking was 2 miles in 35 minutes. That's a rate, 2 miles per 35 minutes, okay? And they want to convert, they want this is the rate, and they want this rate converted over here so that we know how far you could go in 60 minutes at that rate. Because they want to know how far can you go in 1 hour if you walk the same rate. So what we're going to do is we're going to say x, the distance, we want to know how far we can go, because this is distance here, distance over time, or time, distance over time. This is our relationship, right? So 2 is to 35 as x is to 60. So there's our proportion. Now we're going to solve it. So I redrew it over here on this side. 2 to 35, okay, is x is to 60. So what do? We're going, since we got the x on the top, all we need to do is multiply by 60 and we could solve the problem. But I'm going through all the steps just as if it was not quite this easy, just so that you can see the steps. So what we're going to do is we're going to multiply both sides by 60, which will clear the 60 on the right-hand side, and put 2 times 60 on the left-hand side. And we're going to multiply both sides by 35, and you're therefore going to get 35x. So this 2 times 60 on the left and 35 times x on the right. And here's what we have here. So that's the cross multiplication. And once you do that, now you're going to simplify it. So you're going to get 120 is equal to 35x. And now we have to clear the 35 from the x. We have to undo that multiplication. And you undo multiplication with division. So we divide both sides by 35. Well, when you divide 35x by 35, you get x. And when you divide 120 by 35, okay, you're going to get approximately x being equal to 3.43 miles. That's the answer. Approximately, because it doesn't divide out in hundredths, okay, of a mile. So there you have it. So the way it could have been easier is all you really had to do is multiply this side, the left side, by 60, and you'd have cleared the x already. So then you could have just said 2 times 60 is 120 over 35 and skipped these steps here in the middle. It's okay though. We worked it all and we got to see it. Okay, example 6, solving multi-step proportions. And this is a little tougher in that you've got variables on both sides and you've got some adding and subtracting and dividing going on here, and okay, which is okay, but you just take it one step at a time. Remember, you always do the addition, subtraction, and then the multiplication, division. So let's see, hold on a second. Okay, sorry for that. I had to cough there for a second, so I paused the video. It seems like I still have a little bit left. So here's the problem we're going to solve. We're going to solve x plus 4 divided by 5 as we can do that, right? X minus 2 is to 7. How about x plus 4 is to 5 as x minus 2 is to 7? So I'm rewriting the equation like I always ask you to do. Just rewrite it and make sure that, yep, it's the equation. Oftentimes you're going to have in a test, it's going to be written out by the instructor on the test paper. And I'm saying rewrite it. That way you know for sure what problem you're solving. Check it, look back and forth, make sure that every element you wrote down is correct. And now you understand the problem you're going to solve. So what is the first thing you do? We have to clear the denominators here. And we're going to do that by cross multiplying. We're going to multiply the left side by the 7 from the denominator on the right. And we're going to multiply the right side right here by 5, which is the denominator on the left. So that's that cross multiplication going on. So now we have 7 times the quantity, x plus 4, is equal to 5 times the quantity, x minus 2. So now we have to get rid of the distributive property going on here, right? So it's 7x plus 28 is equal to 5x minus 10. 5 times minus 2 is minus 10. 5 times x is 5x. 7x over here, and 7 times 4 is 28. So now we're going to combine like terms by moving them back and forth, okay, around the equal sign. And we'll be using, probably mostly we'll be using the additive or addition property of equality, but let's do it. So we're going to put the 5x on the right, we're going to move it to the left. We're going to take this 5x right here, and we're going to move it over here to the left, and we're going to take this plus 28, and we're going to move it over here to the right. So here you have it. You have 7x minus 5x, because you had to subtract 5x from both sides. And on the right-hand side, we have minus 10 minus 28, because we had a plus 28 on this side over here, and we had to subtract 28 from both sides. Okay, now we're going to combine these terms, and we're going to get what? We're going to get 2x. 7x minus 5x is 2x, and is equal to negative 10 minus 28 is negative 38. Now we have to undo the multiplication with the x with our variable, and we're going to do that by division. We'll divide both sides by 2, and when we do that, we're going to get x equals minus 19, or negative 19. Negative 38 divided by 2 is negative 19. Okay, example 6, check your understanding. So now you get to pause the video and try these 3 problems on your own, see how it turns out. Oops, sorry, 4 problems. 4 problems. Try them out on your own, see how it turns out for you. Okay, so let's do that. Wait, I'll pause while you work on them. Okay, going to finish up with the example 6 here now that you've returned. So problem A says the quantity x plus 2 is to 14 as x is to 10. Well, I'm not going to rewrite the equation because as you see, the slide's full. There are 4 problems and I don't have a lot of room. So let's just pretend like this is me rewriting the equation right here, okay? So what do? We take and we cross multiply. So the 10 will be up on the upper left and the 14 will go up here on the upper right when we're done. So we get 10 times the quantity x plus 2 right here equals 14x. 14 up here multiplied by the x. That's our cross multiply. We have to take the distributive property and get rid of this 10 times the quantity, x plus 2, and it'll become 10x plus 20. 10 times x, 10 times 2. 10x plus 20. And on the right-hand side, it remains 14x. So since there's only one term on the right, I only have to move one term, and that's the x from the left, and so I don't have to do 2 moves. So to do that, I'm going to add negative 10 to both sides to get rid of the positive 10 that's already on the left. And when I do that, the negative 10 and positive 10 cancel, okay? And I end up with plus 20 right here. And then the negative 14 and negative 10, the 14 rather, excuse me, and negative 10 combined to equal 4. So we have 20 right here on the left and 4 on the right. So we're going to undo the multiplication of this coefficient on the variable x. And then to do that, we're going to divide by the reciprocal of 4, which is 4, right? The reciprocal is 1 over 4. We're going to multiply. We're dividing by 4. So 20 on both sides. So 20 divided by 4 is equal to x, or x, I switch the x and the y and the answer back around, which you can do. I said x equals 5. That's the answer for A. For B, we have y minus 15 is to y plus 4 as 35 is to 7. So we're going to do that cross multiply again. The 7 is going to go from here over here to this side, and the y plus 4 is going to move all by itself all the way over here to the right-hand side. And when we do that, we're going to get 7 times y minus 15 right here. And we're going to get 35 times y plus 4, because the y plus 4 came from the bottom left and moved right over here to the upper right. And there you have it. Y times the quantity, 7 times the quantity y minus 15 is equal to 35 times the quantity y plus 4. So now we multiply this out. So to get rid of the distributive property, so we have 7y, and 7 times negative 15 is 105. So 7y minus 105 is equal to 35y. 35 times y, 35 times 4 is 140. 35y plus 140. So now we're going to well, not really, we're going to subtract now. Both of these terms, we're going to get the y term to the right, to the left rather, and the y term and the constant terms to the left. Oh, I'm very dyslexic. I'm sorry today. We're going to get all the y terms on the left and all the constant terms on the right. Excuse that. Okay, and as you see them here, I have 7y minus 35y. The 35y came from the right, minus 105, which is here on the left, and I have a plus 105. That's for me to move it to the other side. And on the other side, I had the minus 35 and the plus 35 right here, from starting with 35 and subtracting 35. And I have 140 plus 105, which are going to add together. And when I do that, 7 minus 35 is minus 28y. And on the other side, 140 plus 105 is 245. If you undo the negative 28 on the variable side here with the y, we're going to get y minus 128y divided by minus 128 is equal to 245 divided by divided by 128. And what are we going to get? Y is equal to negative 8.75. Let's do C. Again, 3 is to w plus 6 is 5 is to w minus 4. We're going to cross multiply. We're going to get 3 times w, here's the w minus 4. It's going to go up here on the left. And we're going to get the w plus 6 to go around here to the right. Okay? 3 times w minus 4 equals 5 times w minus 6. We're going to carry out the distributive property addition or multiplication. So we're going to get 3w minus 12 is equal to 5w plus 30. We're going to move the w's and the constants, the variables and the constants. So I'm going to put the um, the w's on the left-hand side. So I'm going to subtract 5w from both sides. And when I do that, I'm going to get negative 2w. 3w minus 5w is negative 2w. And I'm going to put the negative 12 to the other side, and it's going to be a positive 12 because I'm going to add 12. So it's going to be 100. It's going to be 42. 12 and 30 is 42. So it says subtract 5w and add 12 to each side. And then we simplify it, and the answer becomes w equals negative 21, because 42 divided by negative 2 is negative 21. Last problem. D minus 7 is to 4 as 2d plus 1, little hook they play down here. We got this 2d here now. 2d plus 1 is to 3. So when we solve that, we're going to, again, multiply 3 times the d minus 7. So we're going to get 3 times the quantity d minus 7 is equal to, we're going to multiply the 4, or cross multiply the 4 up here to the upper right-hand side. 4 is to 2d plus 1. Okay, we're going to take care of the distributive property. So it's 3d minus 21 on the left, and it's 4 times 2d, which is 8d, plus 4 times 1 is 4 on the right. So you just multiplied the coefficient of d times this of the 4, and you got 8. So now 3d minus 21, okay, and 8d plus 4, we're going to switch them around. And we're going to move the 8 to the left-hand side, and we're going to move the negative 21 to the right-hand side. And in so doing, we're going to Subtract 8 from both sides, so that's going to give us 3d minus 8d is negative 5d. And we're going to take the negative 21 right here, and we're going to add a positive 21 to both sides. And when we do that, we're going to get 21 plus 4. 21 plus 4 is 25. So we're going to get minus 5d is equal to 25 right here. And then we get rid of the 5 over here on this side. We're going to have d is equal to minus 5. Okay?